In this video, we will talk about CPU scheduling algorithms. We have seen in operating systems that a scheduler present would choose a particular process from the ready queue, and that process is assigned to run in the processor. So the question that we are going to analyze now is how should the scheduler choose a process to run on the CPU from the existing queue of ready processes. So we will now look at several scheduling algorithms, starting from simplest one, that is the first come first serve scheduling algorithm. We have four cases. First one is the first come first serve without arrival time. Second one is first come first serve with arrival time. Third one is shortest job first non-preemptive version. Fourth one is shortest job first preemptive version. The basic scheme in this case is that the first process that requests the CPU would be allocated the CPU, or in other words, the first process which enters into the ready queue would be allocated the CPU. So this is a non-preemptive scheduling algorithm, which means the process once allocated the CPU will continue. So here is an example. Suppose we have three processes with their burst time and we have assumed arrival times as 0. The task is to find the average waiting time. First, we draw Gantt chart according to the processes and their burst time, starting with the first process which has no waiting time. So it will be from 0 until its burst time. The second process will come which has burst time of 9, so 3 plus 9 will be 11, and so on. Second, we calculated waiting time for each process. B1 equal 0, B2 equal 24, B3 equal 27. So the average waiting time will be 17. Second, we will talk about first come first serve but with the arrival time. Consider we have four processes B0, B1, B2 and P3 with their burst time and arrival time. Like the previous example, we should draw Gantt chart at first, then calculating the waiting time. Waiting time will be start time minus arrival time, so B0 will be 0, B1 will be 4, and so on. Then the average waiting time will be 5.75. Third, we will talk about shortest job first CPU scheduling. Shortest job first is a scheduling policy that selects the waiting process within the smallest execution time to execute next. Shortest job first has the advantage of having a minimum average waiting time among all scheduling algorithms. It is a greedy algorithm. In this type, we have two versions, preemptive and non-preemptive. The choice of preemptive and non-preemptive arises when a new process arrives at the ready queue and a previous process is not finished and is being executed. If the next CPU burst of new process is shorter than the current executing process, then in preemptive version, it will stop that process and will start executing the newly arrived process. While in non-preemptive version, even if the arriving process is shorter than currently executing process, current process is not stopped. After the current process finishes, then the new process gets in the queue. This is the key difference between preemptive and non-preemptive version of shortest job first. Preemptive type. Assume we have four processes P1, P2, P3 and P4 with their burst time. In this example, we have assumed arrival times as 0, so turnaround and completion times are same. Process B4 gets executed first as it has the shortest burst time of 3. Therefore, waiting time for P4 equals 0. Process B1 gets executed second as it has the burst time of 6, which is larger than P4 but shorter than P2 and P3. Therefore, waiting time of P1 will be 3, and so on. So the average waiting time equals 7. Second, the shortest job first preemptive scheduling. Let's understand shortest job first scheduling with the help of an example. Assume we have four processes B1, B2, P3 and P4 with arrival time and burst time. Then draw the Gantt chart. First, B1 arrives. It's the only process, so CPU starts executing it. Then B2 has arrived at arrival time of 1. At this time, B1 remaining time equal 5 and B2 has 4. So as B2 is shorter, B1 is preempted and B2 process starts executing. At time equal 2, P3 process has arrived. At this time, B1 remaining time equal 5, P2 remaining time equal 3, P3 equal 2. Since P3 is having least burst time, P3 is executed, and so on. So waiting time will be completion time minus burst time minus arrival time. For example, waiting time for P1 will be 15 minus 6 minus 0 equal 9. So the average waiting time is 3.75.